in which the unknown, that is the variable, appears more than one place, making it necessary that you have to carry out collecting like terms. Let us see how to collect like terms as a skill of solving ordinary algebraic equation. This example says 7x plus 2 minus x is equal to 3x plus 11. Let's use this to learn how to collect like terms. Right, this is example number E. By means of this example, we wish to learn how to collect like terms. Or simply, we want to learn how to unify the unknown. To unify the unknown means to make it appear once in the entire expression, the entire equation. If there is an equation in which the unknown that we want to solve for appears more than one place, then such equation calls for this exercise, this skill we wish to apply here. Please watch the screen and you'll find an example. 7x plus 2 minus x is equal to 3x plus 11. What is the major obstacle in this equation? The major obstacle is that x appears more than once. It appears as minus x, it appears in 7x, it appears in 3x. Here it appears 3 times. It does not mean that each time the unknown appears more than once that it must be 3 times. It could be 2 times, 3 times, 4 times, and more. But in this case, it appears just 3 times. And what is it? Sometimes, when it appears more than once, they appear on one side of the equation. Such equation is easier to handle. Sometimes, like in this case, when the unknown appears more than once, it appears on both sides of the equation. 7x and minus x are on the left-hand side. 7x minus x. Then, on the right-hand side, we find 3x. These are places where x appears in this entire expression. So what do we do? Recall that when the unknown appears more than once in an equation, that there are 2 ways of making it appear once. The first method is collecting like terms, and second method is factorization. The first one, which is collecting like terms, is possible only if the coefficients of the unknown are both constants. If the unknown, that is, if they are like terms, because in this case, for instance, 7x minus x and 3x are like terms. I believe you know why they are like terms. What if they are not like terms but similar terms? We can't collect similar terms. We factorize similar terms. It does not mean that we cannot factorize like terms. In fact, it is by factorizing them that we learn how to collect like terms. It therefore means that that one called factorization is the first method of unifying the unknown. But if we apply it in collecting like terms, if we apply it in like terms, we now call it collecting like terms. But if we apply it to similar terms, then we can no longer call it collecting like terms. What are similar terms? Similar terms are terms that contain the same variable, but not the same set of variables. That means that of the 2 expressions being compared, there is one thing common to both of them. There is one variable that is common to both. For instance, if I say 3x and 3xy, the two are similar, not like terms, because both of them contain 3 and both of them contain x. But y now makes them different and they're no longer like terms. So in this case, please, just bear it in mind that we either factorize or in the simple manner collect like terms. So because these are like terms, we are not going to bother ourselves with factorization. We're simply going to go straight away to collect like terms. Let us now learn the methods, the intrigues of collecting like terms. If you watch this equation here, you observe that this 7x minus x and 3x are like terms, while plus 2 and 11 are like terms. To collect like terms means that all terms which are like terms should be together and alone on one side of the equation. Here, 2 and 11 are like terms, but 2 and 11 are on opposite sides. What it means is that it is either 11 goes out of right-hand side to join this 2 in the left-hand side, or 2 leaves this left-hand side to join 11 on the right-hand side. Any one of them is going to solve. But the first method towards solving this equation is to ensure that all terms are collected to one side. The practice is to collect the terms that contain the variable to left-hand side and collect the terms which are constants to right-hand side. So now our intention is to collect 2 and 11 to right-hand side. What it means is that by this suggestion, these 2 should go and meet this 11, while this 3x should go and meet this 7x and minus x. It does not mean that this is compulsory. It is simply for convenience that we allow or we ensure that the terms that contain the variables are collected to left-hand side and the constants on the right-hand side. Now, the first assignment here is to make these 2 leave this left-hand side and join that 11. How can these 2 move from here to join 11? Is it just by wiping it from that place and making it go to 11? No. We're going to apply the same method of additive inverse. Recall that once this 2 becomes 0, it is as if it no longer exists here. So turn this 2 to 0. Any process that you adopt that correctly makes this 2 become 0 should be done to both sides of the equation, or should be carried out to the both sides of the equation. So whatever process that leads to making this 2 0 should be carried out on both sides of the equation. So once this 2 becomes 0, that's all. It has been removed from that place, leaving us with only 7x and minus 1. So what is that will make it 0? Recall, students, that we said to make a number become 0, add to it its own additive inverse. What is the inverse of this plus 2? Surely it is minus 2. Now see me as I am adding minus 2 to this plus 2. This minus 2 I am bringing here is an effort. This minus 2 I am bringing in here is an effort to make this plus 2 become 0, so as to make it vanish from this left-hand side, while 7x and minus x remain untouched. I am already dealing with this plus 2. Wherever it is found on the left-hand side, this is the way it should be. Now, this minus 2 is what is new. Why is it minus 2 here? It is new and it is introduced into this process. It's allowed. Anything you bring in by intuition into an equation to achieve a goal must be done to both sides if that thing is going to change the value of the side you brought it into. Now I have brought minus 2 into left-hand side, and certainly it's going to change the value of this left-hand side. That is why it has to be repeated on the right hand side. See this minus 2 here. I have introduced minus 2 here, and to maintain this equality, the same thing was done this side. I hope you are following what is happening here. So correspondingly, we say that this 2 is being transferred to right hand side to be collected with 11. 2 is being transferred from left hand side to right hand side to be collected with 11. That is to stay with 11. Now we make progress. Can this left hand side be simplified? Surely. When plus 2 minus 2 becomes 0, 7x plus 0 minus x will surely give us 7x minus x, because whenever 0 is added to something, that thing remains the same thing. And that will now give us 3x plus 11 minus 2. See it here. Class, don't forget that what we're students, don't forget that what has happened here is just that we targeted minus 2. If you become proficient in doing this kind of thing, that is collecting like terms, you can collect all at the same time. That is, collect terms in x and collect terms in constants at the same time. But because you are beginners, because my audience are the beginners, what I'm trying to do here is to ensure that we target one thing and transfer it. Target one thing and transfer it. You too, when you become proficient in doing it, you must not waste time in targeting one term to transfer it each time. Instead, you can do all transfers in one process. Now, let's move on. We now have on left hand side 7x minus x is equal to 3x plus 11 minus 2. Now, left hand side has been simplified. But the like terms have not been fully collected. The constants have been collected fully on the right hand side, but the variables have not been collected. What is preventing the variables from being fully collected? It is 3x, which is still at the right hand side. So what do? Do we just export this 3x and put it in this left hand side cluelessly? No. There must be something that we have to bear in mind. It is the same thing we did before. What is it? If I add the additive inverse of this 3x to this 3x to both sides, this 3x is going to reappear on this left hand side with opposite sign, just as this plus 2 eventually became minus 2 here. This 3x, by the time it appears on left hand side, will become minus 3x. Why? It is because after adding its additive inverse, which is always opposite of that number, we now see that the sign has changed. The inverse of this 3x, which is plus 3x, this 3x is plus 3x, don't forget. So its inverse is minus 3x. Now, look at what I want to do. I want to remove this 3x, which is plus 3x, from right hand side. See me as I do it. This 3x and this 3x are the same thing. Where then is this minus 3x coming from? I introduced it. For what reason? To ensure that this 3x is removed from this right hand side. It is only this that can remove it. Therefore, we can't use minus 5x to remove 3x. If we do it, what we're going to get is something else which is not 0. Therefore, only minus 3x when added to plus 3x can make it become 0. So because this is going to turn to 0 eventually, to leave constants alone in the right hand side, the same thing should be repeated on left hand side. See me as I put the same minus 3x on the left hand side. So something was done here for the purpose of making this 3x here turn to 0. That same thing has been done here for this sign of equality to be maintained. Therefore, if you simplify both sides, at this point, you now know where this minus 3x came from. It came from here because this was added, so it should be added here too. But while this became 0, this did not become 0. Now, this left-hand side is now 7x minus x minus 3x, while the right-hand side now reads 11 minus 2. Students, I hope you now know why there is no more x in the right-hand side. Surely, 3x minus 3x is 0. 0 plus 11 minus 2 is the same thing as 11 minus 2. Therefore, 7x minus x minus 3x. I hope you now know how this came to be. They used to be different places before in the foregoing equation, but now look at them here, collected. All terms in x, one side, then all constants, another side. That means that right-hand side simplified and like terms fully collected. Therefore, simplify both sides. 7x minus x is 6x. 6x minus 3x is 3x. Therefore, the value of left-hand side is 3x. And the value of right-hand side is 9x. Therefore, 3x from left-hand side is equal to 9 from right-hand side. In this case, both sides have been simplified. If we solve this 3x is equal to 9 further, I'm sure that with skills you have already gathered, you will get the answer that x is equal to 3. And that is the solution to that equation. The most important thing learned here is how to collect like terms. The summary is simple. Whenever you collect like terms, from what we have observed so far, anytime you want to transfer a term from one side to the other, add to both sides the additive inverse of that number. And by the time it crosses to the other side, it must have changed sign. This is why many persons prefer to choose a faster course, which is without going through all these philosophical processes. They simply transfer numbers from where they are to opposite side, and their signs will change. For instance, all I have said here will lead to a simple process, which is just take these 2 out of here, it becomes minus 2. Take this 3x here out of here, it becomes minus 3x. So that in the end, quickly we're going to have this without all these intermediate steps we took here. So either way, you are correct, but it is not good to carry out a process without knowing its origin. Those who don't want to bother themselves with the origin should just collect like terms by transferring the numbers from opposite sides to other sides. Okay, from one side to opposite side, and the sign will change. When the terms are already one side, please don't change the sign. When a term is just moving closer to another term without crossing a equality sign, don't change sign. For instance, this minus x is still with this 7x here. Did you see me change its sign? It remains minus 7x. Okay, sorry, it remains x here. It remained minus x here. It also remained minus x here and remained minus x here. It is only this 3x which came from right-hand side that became minus 3x. Therefore, when like terms are being collected and they are already one side, just that they want to be near to themselves without anything coming between them, please don't change signs. But if any number is being transferred from one side to the other side of equation, the simple thing is to transfer it, and then when it arrives that side it wants to go to, it turns to its opposite sign. All right, please check out for this. Right, the question say, unify the variables in the following equations by collecting like terms. Please, it's not compulsory you insist on solving each equation. We just want you to practice one thing, that is collecting like terms. Number A says 3c minus 5 minus c is equal to 7. Number B says 4g plus g minus 3 minus 2g is equal to 1 minus 3g. Number C says minus 2e plus 8 minus 3e minus 2 is equal to 1 minus 12e plus 3. Number D says 11q minus 2 plus 5 minus 2q minus q is equal to 7 minus 6q plus 1. Then number E, that's the last one, says 4y plus y minus 5 minus 3y is equal to 5 plus 2y minus 8y. All right, let's check out for the next example. Right, let's check out for the next example. I said earlier that it is already known that each time a number leaves one side of an equation after being added to its additive inverse, that it reappears on the other side of the equation with its sign changed. We exploit this character in simplifying the process of collecting like terms. How? We just meet an equation and start transferring all the terms that are like terms to other terms to one side. All we do is just change their sign if they are crossing sign of equality, and let them maintain their sign if they are not crossing the sign of equality. So straight away, look at this same question we solved earlier. 7x plus 2 minus x is equal to 3x plus 11. I just transfer these two from here to here to become minus 11, and transfer this 3x from here to here to become minus 3. That's all. And then in the end, we have 3x is equal to 9 is equal to, so that x is equal to 3 after being solved according to the skills we knew earlier. Does that make sense to you? The first method takes time, but it traces why this method we're using right now is clear and applicable. So this alternative method is faster, and many persons who evaluate students on solving equations do not frown at this method. It is faster, but teachers are concerned as to whether students know why these steps are taken as quickly as they have been taken here. Use the first method to know, and this second method, you can apply it during exams and during real life challenges in equations. Again, apply this wherever you want to collect like terms. Just transfer and change the sign.